Unit 4, Lesson 2, Example 3. In this example, I will do the flow proof method of proving two triangles congruent. So again, we're always going to start with our given information and annotate our diagram. So they want us to prove that triangle ABD is congruent to triangle CDB. Alright, so first thing they give us is that AB is congruent to CD. And our only method right now is side, angle, side. We'll have other ones later. Okay, and they give us that AB is parallel to CD. So in this particular example, they only gave us one side. We are looking for an angle and another side. We don't know anything about AD and BC. They didn't tell us anything. We don't know anything about angle A and angle C. Again, they didn't tell us anything. So always with the flow proofs, I like to put what I'm trying to prove at the bottom. ABD is congruent to triangle CDB. And for this particular example, because I only have one method, I know that's going to be because of side, angle, side as my reason. So what am I going to do next? Well, I know that from those useful hints that I should look for a vertical angle, which we do not have, or I should look for a shared side between those two triangles, which we do have, which is BD. So from the given, I have AB congruent to CD. That was given. That gave me a side. I'm going to get another side from BD being congruent to itself and being part of both triangles. And that's from the reflexive property. And so what I'm missing is the angle piece here, right? We're missing an angle. Okay, well, they gave me that these two lines are parallel, and so I need to think of something that I can use there. And I have a side and another side. And I know that in order to get an angle, it has to be included or in between those two sides. And so again, in the other triangle, I have the same side and this one, and so the angle must be in between those. So if I look at these right here, these two angles, I'm given parallel lines and I have these two angles here. These are alternate interior angles, and because those lines are parallel, AB and CD are parallel, I know that those two angles, which I'm going to call 1 and 2, are congruent to one another. So we have to always build from our given information AB parallel to CD. Given. From that, what do I know? I know that angle 1 is congruent to angle 2. In Unit 2, I had you first state that angle 1 and angle 2 are alternate interior angles because I was trying to stress to you that they are considered alternate interior regardless of whether they are congruent or not. The proofs are going to get really lengthy and require a lot more steps, so we can cut that step out. However, it is because we are given that the lines are parallel. So again, your reasoning down here is going to be one of two things. So you can say alternate interior angle theorem, if you remember what that means, or you have to write what it says, what that theorem states, which says when two parallel lines are cut by a transversal, the alternate interior angles are congruent. So if you don't remember alternate interior angle theorem, you need to state what it says. When two lines are cut by a transversal, the alternate interior angles are congruent. So because those lines are parallel, and they gave that to us, we can say that the alternate interior angles are congruent. And so now I've completed my proof by side, angle, side. I've shown that angle, that included angle, and now we're going to do the last piece. Describe the rigid motions that would map CDB onto ABD. So remember that a parallelogram, which is this figure we have here, has no lines of symmetry, so we can't really use a reflection to reflect this triangle onto the other one. However, it does have rotational symmetry, so I can say one of two things here. I can do a rotation centered at the midpoint, 180 degrees, a midpoint of BD, 180 degrees, will map, triangle CDB onto triangle ABD. Or I can say a rotation, 180 degrees, centered at point D, followed by a translation. And again, I must state what point maps to what point or include a vector, D to B. And that's it.